Greetings, pre-calculus students, to another lesson in our unit on the unit circle and trig. We are continuing our graphing phase of the unit, and today's lesson we're going to take a small, teeny tiny break from graphing, which we've done the past couple days, and we're going to focus on the second bullet point on this objective slide, which is being able to write trigonometric equations given the graph already. Okay, so given a graph, determine what the equation is. Now, we've done some simple things like find the amplitude and period of a trig function given its graph, but we've never determined the entire graph itself. We've never determined the entire equation itself by looking at its graph. So that's what we're going to be doing in today's lesson. So, we'll start off with these first two graphs. So write a possible trig equation for each write a possible trig equation for each given graph. Well, hopefully you remember from our previous lesson on amplitude and period that the sine and cosine function both have the following structure. Okay, so for sine, you have f of x is equal to a sine of bx. And then for cosine, you have, let's say, g of x is equal to a times cosine of bx. And if you recall, the a value is your amplitude, and the b value, all right, remember the b value determines your period, right? There's that little formula, period is equal to 2 pi divided by b. So we're going to be using both of those forms in our answers. Okay, so let's look at this first example here. Okay, so part A, example 1, part A. So write a possible trig equation for each given graph, and we're going to find the amplitude and period, because by finding the amplitude and period, we can determine what that A and B value are for our equations. Now, first we have to determine whether this is sine or cosine. Now, there's a really easy way to tell if your graph is a sine or cosine graph, and it all has to do with that y-intercept, all right, that y-intercept, okay? So for this first graph, since the y-intercept is 0, okay, right, it crosses through the origin, so since the y-intercept is 0, that means our equation is a sine equation, all right? That means our equation is going to be a sine equation, okay? So if your y-intercept is at 0, that means you have a sine graph, all right? So, since y-intercept equals 0, sine graph. Okay? All right, so let's determine the amplitude. Let's determine that amplitude. Well, let's see. Well, remember, the amplitude is half the height of the curve. Half the height of the curve. Well, remember, we determine the height of the curve by simply taking the highest point minus the lowest point. All right, so let's see here. So the highest point is 3. The lowest point is negative 3. All right, so let me just do this here at the bottom here. So the height is equal to 3 minus negative 3. So that gives us 6. So the height of this curve is 6. And the amplitude would be half that. So that means the amplitude is 6 divided by 2, giving us 3. Okay, so that's our amplitude. And if you recall, not only is that our amplitude, that is also our A value. So that means that is the number that goes out in front of our equation. Forgot to put that X there. Okay, we got that X. All right, so now we have the period. Well, remember, the period is how long does the curve take to complete one cycle? How long does the curve take to complete one cycle? Well, let me highlight it here. So it looks like this curve takes 1 pi to complete one cycle, right? Because from there it just repeats the same curve pattern over and over, right? Here's another cycle. If we wanted to go the other direction, this is another cycle. And then this is another cycle, right? So each cycle, remember, has to be the exact same. That's how you know that's one period. That's how you know that's one cycle, because each of those highlighted parts of the curve look exactly the same, okay? All right, so it looks like it takes us 1 pi, because remember, it's the horizontal distance, so you're looking at the x-axis. So from here to here, it took us pi. So that's our period. Okay, so our period is pi, or 1 pi. Now, don't forget, though, that is not our b value. Remember, I mentioned this earlier. The period is not your b value. You use the b value to find the period, but it is not one and the same. Well, now we have to determine what the b value is. Well, how do we do that? Well, we're going to use that little formula. Okay, we're going to use that little formula. Remember, the period is always equal to 2 pi divided by b, right? The period is always equal to 2 pi divided by b. Well, our period this time is pi, right? So I'm going to set that equal to that little formula. So pi is equal to 2 pi divided by b. All right, so 2 pi divided by b. So we're going to solve this equation. Okay, we're going to solve this equation by multiplying both sides by b. Okay, let's multiply both sides by b. So we end up with b times pi is equal to 2 pi, right? B times pi is equal to 2 pi. And then we want to solve for b, right? We want to solve for b. So we're going to divide both sides by pi. Divide both sides by pi. And it looks like on the right side of our equation, the pi's cancel out. The pi's cancel out because we have one in the numerator and the denominator. So it looks like, if I go in this direction, it looks like b is equal to 2. Okay, that is your b value for this problem. That is your b value for this problem. Okay, so once again, you gotta use that little formula, that 2 pi over b formula, to determine what that b value is, except this time you're working backwards, since we know the period, and we're trying to figure out what the b value is. So here is our equation. Y equals 3 times sine of 2x. Y equals 3 times sine of 2x. So there's our sine equation. Now let's do a cosine one. So part B. Okay, so once again, we have to determine first if this is a sine or a cosine graph. I already said it was a cosine graph, but how do I know? How do I know this is a cosine graph? Well, once again, it has to do with the y-intercept, all right? You know it's a sine graph if the y-intercept is 0, okay? If the y-intercept is 0, it's a sine graph. If the y-intercept is a max or a min, okay, so if the y-intercept is a max or a min, in this case it's a max, then it's cosine, all right? So y equals cosine, and then those parentheses there, all right? So since y-intercept is a max, cosine graph, okay? So if your y-intercept is either a max or a min, okay, if your y-intercept was this point, for example, instead of this point, it would be a cosine graph still, all right? All right, so now let's go back to the amplitude. Well, once again, the amplitude is half the height of the curve. Well, let's determine what the height of the curve is first. Well, the highest point on this curve is 4. The lowest point is -4. So let's do that. So the height is going to be the highest point minus the lowest point. So that gives us 4 minus -4, so that's 8. So that means the amplitude is half the height. So that gives us 4. So the amplitude of this graph is 4, which means the number in front of the equation is also 4, because that is our a value. All right. Now let's do the period. All right. Now let's do the period. Well, let's see. It looks like this curve takes, if I keep on going, it looks like this curve takes 2 pi to complete one period, right? Because if I were to just continue on from there, it would just repeat the exact same pattern or the exact same shape again and again and again. All right? So it looks like our period this time around is 2 pi, because once again, we're looking at the x-axis. How long does it take on the x-axis to finish? And it looks like it takes 2 pi to complete one period or one cycle. So our period is 2 pi. Okay, our period is 2 pi. Well, now we got to calculate that b value. Okay, now we got to calculate that b value. So let me go down here. Okay, so just like the previous one, we're going to use that formula. So we know the period is equal to 2 pi over b. Well, in this case, our period is 2 pi. So we can set it as 2 pi is equal to 2 pi over b. And once again, we're going to solve for b. Now, some of you might be able to figure out, okay, wait a second. If this is our equation, that means b has to be equal to 1, right? Because 2 pi divided by 1 gives you 2 pi. But let's solve it algebraically just to go through the steps to show that it is indeed equal to 1. Okay, so we solve both sides by b. Okay, solve by both sides by b. So we end up with b times 2 pi is equal to 2 pi. And then we're going to get that b by itself. So we're going to divide both sides by 2 pi. Divide both sides by 2 pi. And that cancels out. And 2 pi divided by 2 pi is just 1, right? If you divide something by itself, you just end up with 1. So that means b is indeed equal to 1. So that means the constant in front of our x is 1. And technically, you don't even have to write 1 there at that point, because since 1 and x are just being multiplied, right? Even if you didn't write a 1, it's implied that there is a 1 there anyways. So that is our final answer for this cosine graph. Y equals 4 times cosine of 1x. Okay? So that's finding the equation of a sine and cosine graph. Now the next two examples I want you to do on your own. Okay, so C and D I want you to do on your own. Identify the amplitude, identify the period, identify the equation. Remember what I just covered in the previous slide as to how you know whether it's sine or cosine. Okay, one of these is sine, one of these is cosine. So I'll just tell you right off the bat. And then you go from there. Sorry, I was just thinking there for a second here. All right. Let's go through one more example. Okay, one more example. Okay, so sorry about that. So once again, these two problems on your own. Okay, on your own. All right. So now let's talk about. All right. Now let's talk about one more example. Okay, so find an equation given each set of conditions. Okay, so this time you're given a description of a sine function or a cosine function, and then from there you're tasked with actually writing an equation. So part A, a sine function that has an amplitude of 4, a period of pi. Okay, so we've actually done this before, where we were given amplitude and period and then tasked with writing out an equation. So I'll just do this first one, and then the next two, or actually let me see, which one? You know what, let me do B only because B with the fractions is probably the trickiest of these three. So let me do B, and then A and C you can do on your own. So for B, a cosine function that has an amplitude of 3/5 and a period of 3 over 2 pi. Okay, so remember the amplitude, that's our A value, and then our period, we use that to determine what the B value is. All right, so let's see. So the A value is 3/5, so now let's use the period to determine what the B value is. Okay, so the A value is 3/5, and the B value, let's use that little formula, okay? So remember the period, okay, the period is equal to 3 over 2 pi, okay? And we also know that the period is also equal to, I can also write it this way, 3 over 2 pi is equal to 2 pi over b, because that's what the period is equal to. So now let's solve it like we did in the previous problem. Okay, let's multiply both sides by b. So that cancels that out, and we are left with b times 3 over 2 pi is equal to 2 pi. Okay. All right, let's see what we're going to do here. Let's divide both sides by pi to get the pi out of the way. Okay, let's divide both sides by pi, and then we'll take care of the fraction. So let's divide both sides by pi. So that cancels out, and that cancels out as well. So it looks like we're left with b is equal to, whoops, whoa, got ahead of myself there. B times 3/2 is equal to 2, because all those pi's canceled out, since we divided both sides by pi. Now, to get rid of 3/2, the easiest way to do it would be by multiplying both sides of the equation by the reciprocal. So let's multiply both sides of the equation by the reciprocal, which is 2/3 in this case. The reciprocal of 3/2 is 2/3. Okay, so let's do that. Because by doing so, those cancel out. And then we're left with, it looks like we're left with b is equal to 4/3, right? Because 2 times 2/3 is 4/3. So that's our b value. We figured out our b value. We figured out our a value. Now we just got to do the equation. So y equals 3/5, because that's where the a value goes, cosine of 4/3 x, because that's where the b value goes. All right. So a value, and then that b value. All right. And that's it. That's all you have to do to figure out what the equation is. With this one, it was a little bit trickier because of the fraction. So hopefully A and C are a little bit easier since those only deal with whole numbers. Though you do want to make sure you know how to deal with fractions as well. Okay. So at this point, example 2A and C. So example A and C on your own. Okay, so example A and C on your own. And that is it for today's lesson, folks. Not a very long lesson, once again. We really just built upon the ideas covered in previous lessons with this idea of writing an equation, this time given a graph, so requiring us to look at the visual aspects of the function in order to determine what the equation should look like. Otherwise, let me know if any questions pop up. As usual, in that last lesson, a few of you did point out the fact that a certain aspect of the topic was a little bit tricky, so that is always helpful for me, because that way I can better address the confusions in class once we come back together. Otherwise, I hope you guys stay safe, and I hope you enjoy the rest of your days.